So we have a police cruiser approaching from the north. So the way the picture would look is, here's the intersection. So we have the police cruiser and it's coming from the north. The car is moving straight east. So here's the car. So I'm going to use the variable P for police and C for car. Okay. And then this is also moving because the distance between them is moving. So it says when the cruiser is 4 miles north, so when the police car is 4 miles north, the intersection of the intersection, the car is 9 miles east. The police determine that the radar, the distance between them is increasing, so I'm going to call this Z. So DZ is 17 miles per hour. So the distance between them is increasing at 17 miles per hour. And then they're also given that the cruiser is 47 miles per hour. So DP, the rate of change of the police is 47. We are trying to determine the rate of change of the car. So the way I'm going to put these all together, I'm going to use Pythagorean theorem. So it's going to be the police cruiser squared plus the car squared equals Z squared. Now, in previous lessons, we always used to be able to substitute one of these variables because it's constant. In this specific case, none of them is constant. The police cruiser is constantly moving, the car is constantly moving, and the distance between them is constantly moving. So nothing is constant. Remember that P equals 0.4 and C equals to 0.9 is a specific moment in time. So we need to find the derivative for all moments in time. So it's going to be 2P times the derivative of P plus 2C times the derivative of C is equal to 2Z times the derivative of Z. So we're going to substitute all the information that we know, but one of the things is we don't know Z, and I'm going to need Z for my equation. So I'm going to go ahead and solve the Pythagorean theorem for Z. So I'm going to have 0.4 squared plus 0.9 squared, and that's going to be equal to Z squared. So that's going to give me 0.97, and then Z squared would be 0.98489. Remember for your calculator to make sure that you store this in a specific equation, because I just chopped it off at 5 decimal places, but you need to do all your decimal places, otherwise you're going to get an answer that's off. So I'm going to go ahead and solve for DC, because that's what I'm trying to solve for. So I'm going to subtract 2P dP from both sides, and then I'm going to divide by 2C. So I'm going to go ahead and substitute all my numbers. So Z, we had 0.98. Remember to use all your decimals on your calculator. It's a little bit smaller, otherwise it's not going to fit. So even though I'm just, like I said, I'm only putting 0.98, I'm going to use all the decimals on my calculator times the rate of change of Z minus 2 times where the police cruiser is times the rate of change of the police cruiser divided by 2 times the distance that the car is at. So that's going to give me 0.98 times 17. One of the things that I did first is noted that they all have a 2. So I canceled the 2 just to make the calculation easier. You don't have to, especially since we're using a calculator. We can just substitute all of this in our calculator. So this comes out to 35.543 divided by 0.9. So that is 39.492, and my units are miles per hour. So the cruiser is going at 39.492 miles per hour.